All good. Today, we're going to learn just an added trick when we don't have a whole lot of information. Okay, so I'll talk about determine the mean and standard deviation without the TI 84. And basically what I will say here is I will remind you of the fact that, oops, come on, focus, you can do this. No, I'm not going to focus. Technical difficulties. There you go. Now we're back. Okay, so I will just remind you of this. Let's just sketch a curve here real quick. We have our center, which is the average. 1, 2, 3. We go back to the mean. 1, 2, 3. So this is 1 standard deviation, 2 standard deviation, 3 standard deviations. Then we have -1 standard deviation, -2, and -3. Okay. So I want to focus on the number of gaps. Okay. So if I were to say plus or minus 1 standard deviation, right? How many gaps would we have to consider? If you go from -1 to +1, how many gaps are there? 2, right? 2 gaps. If it's plus or minus 2 standard deviations, right? You go back -2 and then +2. We have 1, 2, 3, 4 gaps in between. Plus or minus 3 standard deviations, you can probably tell, you just multiply that number by 2, right? If it's plus or minus 3 standard deviations, we'll have 6 gaps. That's basically from n to n, from -3 to +3. So we have 1, 2, 3, 4, 5, 6 gaps that we're considering. Okay? So I'm just going to give you these formulas and we will practice them in a bit. So to find the mean, you would take the high plus the low and you just divide it by 2. Okay, let's put brackets on the top. So write that one down and I'll box it in. And to find the standard deviation, we would take the high, but we're going to go minus the low. We're going to divide that by the number of gaps. These two formulas, I would encourage you to have these on your study sheet, because you will be given times where you only have 2 values, right? And I will ask you, hey, find the mean or find a standard deviation just based on the values and the number of standard deviations that they're separated by. Okay. So for example, uh, 95% of bags of grain weigh between 56.4 kilogram and 65.6 kilograms. Calculate the mean weight. B, determine the standard deviation. And now I'm trying to think, like, I need to help you out a bit more here. So we're going to go back up to this. What percentage of data falls within one standard deviation? 68, right? 2 standard deviations? 95, right? Within 2 standard deviations, remember the rule, 68, 95, 99.7. So sometimes you'll have to just make a connection between the percentage that I give you and how many standard deviations exist between them, okay? So for A, to find the mean, the high, like they gave you a range, right? So the high is 65.6 plus the low, which is 56.4, because you know that if they're 95% or in between, that they're both the same distance away from the mean. They're 2 standard deviations, so we can do this. We can add these up and divide it by 2. And that gives you 122 divided by 2, which is 61 kilograms. So if you were to graph your curve, your normal distribution, this is the number that would be in the middle. Okay? B, standard deviation. So standard deviation is the width of those gaps. Remember that. The bigger your standard deviation, the flatter your curve will be. Smaller standard deviation, it will be compacted, narrower, and steeper. Okay? So standard deviation, I take the high, but I subtract the low from it. And here's the kicker. This is where it all comes down to. What am I going to divide it by? It says 95%, right? So I'm going to highlight that. 95%, so I'm going to go arrow, and I'm going to go down. And so 95% would tell me that these data points, like these two numbers, are within 2 standard deviations, plus or minus. The 95 is connected with plus or minus 2 standard deviations, which tells me that there are 4 gaps. And so that is the number that would go in here. Okay, so the difference between these two divided by the number of gaps, which I've determined is 4, based on that 95%, right? So it will be very specific. I won't just give random percentages. You should recognize that percentage. And so when you subtract them, let me see here, that is 9.2 divided by 4. That's 2.3 kilograms. Okay, so you just found the mean and standard deviation just like that. You did not use your calculator other than actually typing in the numbers, but you did not use normal CDF or anything like that. In fact, you couldn't do it. So just keep that in mind, okay? So it's high plus low. It's always divided by 2. It's fixed, right? I don't know. I don't want to mess it up too much. So this is not fixed, right? Because we go back to our formulas. This is gaps. So this could be, watch this. It can be 2, 4, or 6. Those are your only options. You have to figure that out based on the question. This is always 2, all right? So this is fixed, but the standard deviation is not. You have to read carefully. If it had said that 99.7% of bags weigh between this and this, right? You would still subtract them, but you would have had to divide them by 6, right? Because you're recognizing, oh, that number tells me that it's within 3 standard deviations to either side of the mean, which represents 6 gaps in between, okay? And that is that. You could now graph, right? You could graph, you could make a normal distribution, right, with the middle 61, and then you go up by 2.3 this way, 2.3 going this way, and you could actually confirm that it all matches, right? You should have these two values on your normal curve as you move along, okay? All right, we're gonna write the AC now. This is all I wanted to cover, basically, when you get something like this. And it'll come back in the AC you're gonna write now, and it will also come back in ACs you write tomorrow, okay? I'll pause it there. So maybe I should start off by saying that yesterday we learned that to get the z-score, we got to go value that you're interested in finding the z-score for minus the average of the data set it's found in divided by the standard deviation, okay? And to find an actual value, right, you multiply z times the standard deviation, and you would add the average of that data set. So those two formulas are in play at first for the first 6 questions, okay? So I will just do one in each, and then the rest I'll just give you the answers for. So for example, calculate the z-score if the average is 5.3 and the standard deviation is 1.2 centimeters. So for this particular value, right, it follow the formula. It's 6.38 minus average divided by standard deviation. And I always assume that there are brackets. And so when you type that in, you divide by 1.2, you get a z-score of 0.9. No units for z-scores, okay? Z-scores tell us how far from the average you are found, whether to the right or to the left. So this is almost 1 full standard deviation to the right of the average. So if we're talking height, well, can't really do height, but length of this particular object, you'd be on the higher end, right? And so the z-score for 4.92 is negative 0.32. The z-score for 5.14 is negative 0.13. Okay, so we'll give you 1 mark for each. So that's a total of 3 for the first 3 questions. Then 4 to 6, calculate the given value if the z-score, right, for each z-score, if this is my average, this is my standard deviation, we have no units. So for here, the actual value, I'm going to go z-score, right? Standard deviation is 0.91 plus the 2.24 average. And if you type that in one shot, you get 0.49 units. So we don't know what we're talking about, right? If it's grams, centimeters, hours, minutes, we don't know that. So if you just put 0.49, you're fine. In this particular case, you go, right, that's the value you're interested in. Sorry, that's the z-score, my bad. z-score times standard deviation, which is 0.91, plus the average is still 2.24. In that case, it's 3.26 units, the actual value. And here, the actual value is 3.05 units. So we give you 3 marks for that. So 3 and 3 is 6 so far. This one should be, like if I ask you, like if I give you the information, like calculate the z-score, is basically just plug in, right? Just plug in and go. And let's keep going here. Given the following z-scores, calculate the probability. So here's that probability, the percentage, the likelihood, right, of each event happening. You should be thinking normal CDF, okay? So a z-score less than, having a z-score less than 3.47, so you got to go minus 1 million. 3.47 is the z-score you're after. What's my average? 0, right? When we're talking z-scores. And my standard deviation is 1. You multiply that by 100, and I'm running out of room here, but that's 99.97%. Because think about it, a z-score of 3.47, like you're past positive 3 even further, so it's almost the entire normal curve is included in this, right? A z-score greater than negative 2.34, so here you're below the average, so you gotta go normal CDF. I always want you to write this out and include all the entries if you're using normal CDF. Because we want percentage greater than this is our lower limit, and this is our upper limit. My key probably only has 1,000. Like if you see my keys, I don't use 1,000,000, but sometimes it has been an issue when we're dealing with big numbers to begin with. So I just say use that million and you'll be fine. So here you have 99.04%. So I want very specific answers there. 9 z-scores between these two values. So I'm almost more interested in seeing the entries you use. I also want the correct answer, of course, but so if you find that the normal CDF there's 92.98%. Okay. 1 mark each so far. This is where it gets a little trickier. You can do this in steps. So z-score is less than this or greater than that. So this is where you want to find less than 0.5 negative, right, and greater than. You want both of those chunks, right, together. So we're going to go normal CDF is negative 1 million all the way to negative 0.501, right? And I'll just write down what that is. That is 0.3085 for now. I'm going to multiply that later on. So that's just getting this first part, or greater than that. Normal CDF 1.5 to 1 million 01. This gives me 0.668, right? And so you need to add those two together. This or that, right? You need to add it together. So total is 0.3085 plus 0.668. And so that gives me, I will state it as a percentage already, 37.53%. We will definitely make this worth 2. Okay, we will make question 10 worth 2 marks. Okay. Is there another way of doing this? There is. I did it the long way. I'm just going to grab some scrap paper because it's important for you to know. Yeah, sorry. I'm just going to leave it like that. I'm going to cut my losses here. That's the fail safe. You get it right every time if you do it that way. What percent of normally distributed data falls between plus and minus 2 standard deviations? 95%, a nice and easy one. Calculate the standard deviation if the majority, which I told you is 99.7%, of the data falls between these two numbers. So here you have to go standard deviation is high minus low divided by 6. So that would be 55 centimeters is my standard deviation. You get one. We'll just do 1 mark today because it's fresh. Calculate the mean of this. So I will just tell you that, right? One variable stats, but that would be 60.13 units. The median would be 60.5 units. And the standard deviation would be 29.40 units. 1 mark, all of that is just 1 mark. So if we add this up, it's out of 16. I will take this